comprehensive set of questions you have to ask about a model in order to be sure that it's not memorizing some artifact or hacking your reward function or doing all of the things that models are likely to do when they're consuming a lot of data and heavily optimized toward an objective. To that point, like the example within drug discovery and development is the success of AlphaFold, which was built on decades of accumulated structural data with sequence to structure relationships across, hundreds of thousands of proteins. But, as you gestured at earlier, chemistry doesn't really have an equivalent. So there's the relation, and my understanding is that that's because the relationship between chemical structure and biological activity is much more complex, but also that the data is more fragmented and much of it is proprietary. So I'm interested in your perspective on how data scarcity shapes what's possible computationally in small molecule drug discovery.
Yeah, I think both of those things are true. In biology, some of these sort of large language model type methods, dealing with strings of characters, work quite well for bioinformatics and so on. So I think there's a more natural match between there and the building block reservoir protein of proteins is only 20 amino acids and so on, and the structures consist of lots of regular repeating helices and sheets and so on. So whereas chemistry, it's far more diverse in terms of the chemotypes and the sizes. It's just a lot harder problem. And in terms of the data, again, we just don't have that data where there's associated lots of chemical data, but not so much where there's associated relevant biological data. And I just reminded that was I think it was a few years ago now, so it's maybe 3 years old, but but I think it's still true. There was a Nature editorial, the title of which was, "For chemists, the AI revolution has still to happen." And it was just, again, making this point that there just isn't that set of data, not even for something straightforward like binding affinity. And then if you go to metabolism, where there are hundreds of metabolizing enzymes, or if you go to other things, how we could build models that could be effective in those areas when the data is so scarce and so diverse. Different labs produce different results, and so on and so forth. Quite a lot of it's locked away in big pharma vaults. So they perhaps internally, some of the big pharma companies have enough data to do something useful with some of those models, but not an awful lot. Although there are efforts to put these things into the public domain in a pre-competitive sort of way. That's still pretty much lacking. So it's an enormous impediment, I think, to generating good models in chemistry.